All right, for this next one, I'm going to use the same approach as the last one. Start with the ratio test. I'm going to take the limit as n goes to infinity of the absolute value of the n plus first term divided by the nth term. I have to make sure that this is less than 1. So I'm going to figure out what x values can I put in to this expression that will make that limit be less than 1. Do this in a different color so I don't get confused. Okay, the limit as n goes to infinity of the n plus first term. So my x has nothing to do with the n, so that doesn't change. 2x plus 1 to the n plus 1 over n plus 1 plus 1, which is n plus 2. And then instead of dividing by a sub n, I'm going to multiply by its reciprocal. So this is n plus 1 over 2x plus 1 to the nth. Simplify this, becomes the limit as n goes to infinity. 2x plus 1 to the n plus 1 over 2x plus 1 to the n. When I reduce that, I'm going to have 2x plus 1 to the first in the numerator, right? These are like bases. You subtract the exponents. N plus 1 minus n is 1. So this is going to have a 2x plus 1 in the numerator. And then n plus 1 over n plus 2 doesn't reduce at all. You cannot simplify that. So because the 2x plus 1 doesn't have anything to do with n, I'm taking the limit as n goes to infinity. X is not bothered by that limit, so I can pull it right out of the limit. I have the absolute value of 2x plus 1 times the limit as n goes to infinity of n plus 1 over n plus 2. Now that limit is 1 because the degree of the denominator and the numerator are the same. I take the ratio of the leading coefficients. So this goes to 1. So that becomes the absolute value of 2x plus 1 times 1. And then I have to make sure that I only choose x's that will make this limit less than 1. So if you remember how to translate an absolute value inequality, it becomes a sandwich. -1 is less than 2x plus 1 is less than 1. And I solve the inequality by subtracting 1 from both sides, or all 3 sides, and then dividing all 3 sides by 2. So I end up with -1 is less than x is less than 0. So that's my interval of convergence without checking the endpoints. So this is my open interval of convergence. But I do need to check my endpoints -1 and 0. Does it converge at -1 and does it converge when x is 0? So let's see, I'm going to do that down here. So when x equals -1, I'm going to plug into my original series. I have the sum from n equals 0 to infinity. Replacing my x with a -1, I have 2 times -1 is -2, plus 1 is -1. So I get -1 to the n over n plus 1. That is going to converge because it is similar to the alternating series, the alternating harmonic series. You could check it with the comparison test or the limit comparison test. So this converges, which means I can add an or equal to on my interval of convergence on the -1. And then when I check x equals 0, in my series, I replace the x with a 0. I end up with 1 over n plus 1. And that is going to diverge because, again, it is similar to the harmonic series. You can check it with the limit comparison test. That diverges. which means I cannot put an or equal to sign on the 0. So my interval of convergence is -1 to 0, including the -1, but not the 0. So if I draw a picture of this, -1, 0, my interval of convergence looks like this. The center would be at -1/2, which means that my radius, r, is 1/2. Radius of convergence is 1/2.